Welcome back, students. Today we're going to be talking about scatter plots and how to interpret them. Now, a scatter plot is just a graph that shows the relationship between two data sets. The two data sets are graphed as ordered pairs on a coordinate plane. Scatter plots can show trends in the data, meaning that they can show patterns. So over here to the right is an example of a scatter plot. The scatter plot to the right shows the amount in grams of sugar and the number y, and the numbers of calories in 10 smoothies. So the amount of sugar is x and the calories are y. Now notice what's happening. Hopefully this isn't news to any of you. The more sugar there is in the smoothie, the more calories there are going to be as well. But let's go ahead and look at some of these questions so that we can see how to interpret some of the basic parts of the scatter plot. So first, we've got how many calories are in a smoothie that contains 56 grams of sugar. Well, let's see where 56 would be. 56 should be between the 54 and the 58. So we have a dot right there to tell us that. So it was 270 calories. Okay, how many grams of sugar are in a smoothie? Excuse me. How many grams of sugar in a smoothie that contain 320 calories? So I'm going to start with the calories up at 320. And we've got an example of a dot over there. So with that particular smoothie, that smoothie had 70 grams of sugar. Okay, so each of those dots represents two different data sets. They represent grams of sugar and they represent calories. And each of them is a different smoothie. Okay, so hopefully that drives home the idea of what a scatter plot is. Each represents an individual entity that we can measure it in two different ways. In this case, the two ways were sugar and calories. Now, what tends to happen to the number of calories? So how is calories changing as a number of grams of sugar increases? Well, the more sugar we have, the more calories. As sugar goes forward, calories go up. So I'm going to say that calories increase. That's what tends to happen. Okay, now that is not a 100% kind of thing, because you'll notice that from this one to this one, the sugar increased, but the calories did not. But that's not what we were looking for. When it says this word tends, we're looking for the overall pattern. So the existence of a single point that doesn't match that pattern doesn't really matter, because overall there is this trend of the data that as sugar goes up, calories go up. So now let's talk about correlation. Correlation. Co usually means with. Relation, it's a relation. Okay, so we've got a relation with something. In this case, are x and y variables. When you notice a clear pattern in a scatter plot, that means there is a correlation. There is a relationship between the two variables, or at least the numbers would indicate one. We then have to do further studies to prove that there is a relationship. But that's a tale for another time. Right now, let's just go ahead and look at these patterns. Now, in this one, as x increases, we notice y increases with it. We call that positive correlation. As x increases but y is decreasing, we call that negative correlation. And when the dots are scattered and you can't seem to see a pattern in them, that is called no correlation. There is no relationship between those two variables. All right, so let's just quickly identify some correlations. Just looking at these dots, I don't see much of a clear pattern here. Maybe ever so slightly they seem to be going up, but even that's not, it's not very clear. And so I'm going to go ahead and say that there is no correlation here. So this represented the number of vehicles owned and a person's age. Okay, so what age you are apparently is not a good predictor of how many vehicles you currently own. Okay, so there must be other things going into. I would wonder if perhaps we had income here. If we put in income, if as income goes up, if the number of vehicles owned goes up. And that might be something that would have correlation. But as we see, the age and the number of vehicles owned doesn't appear to have correlation. One is not a good predictor of the other. Next, we've got temperature and coat sales. Well, pretty clear pattern there. So as X goes forward, Y goes down. So this is a negative correlation. So X was the average daily temperature. So as X is going forward, that means the temperature is rising. So as the temperature is going up, the number of coats they sell goes down. So it doesn't take a genius to figure out why that happens. All right, negative correlation right there. All right, using lines to fit and model the data. Now you'll notice on this previous problem to kind of show the pattern, I drew a quick line there. That line is something we could call a trend line. They are also going to call it a line of fit here. We've got some steps in order to create these lines of fit. First, make your scatter plot of the data. Decide whether or not it can be modeled by a line. Certain data might show a clear pattern in it, but that doesn't mean it's a linear one. Some patterns can be exponential in nature. So just because you see a pattern doesn't mean we can fit it with a line. And in fact, fitting a line to different types of patterns will yield poor results. Next, step 3, draw a line that appears to fit it closely. There should be approximately the same number of points above the line as below it. Okay, so you're trying to go through the middle of your dots, so to speak. Then you're going to write an equation using 2 points on the line. These points don't have to be actual data pairs, but they should be on your line of fit. Okay, so we're going to be using 2 points to create an equation. Y is equal to mx plus b. Okay, so you may want to view a previous video on how to use 2 points to calculate a line. But that's essentially what we're going to do. We're going to get 2 points and use those to figure out y equals mx plus b. All right, so this table shows the weekly sales of a DVD and the number of weeks since its release. We want to write the equation that models the DVD sales as a function of the number of weeks since its release. Then, very importantly, here's something new. We want to interpret the slope and the y-intercept of our line of fit. We want to say what the parts of the equation actually tell us about the relationship. All right, so let's start with step 1. Let's just get the scatter plot made. So at 1 week, it was at 19 million. At 2 weeks, 15 million. 3 weeks, 13 million. 4 weeks, it's at 11 million. 5 weeks, at 10 million. 6 weeks, at 8 million. 7 at 7, and 8 at 5. Okay, so I am now going to wait for the bell. I am now going to draw a line that tries to go through the middle of this to the best of my abilities. Okay? When you are doing a trend line or a line of fit, these are kind of quick things done by a statistician to get some quick numbers. There is, and we will learn next time, a line of best fit, okay, or a linear regression. These are going to be calculated through very specific algorithms and equations to provide the best match. But for right now, we're just going to do this free form. So let's draw this line. I'm not hugely happy with, let's see. Yeah, all right, I feel better about that. So I've got like these two above, those 3 below, and then another one above, and then it looks like it's kind of on. So I got a similar number above and below, and that's what I was going for. Okay. All right. So now I've drawn my line. The next step is we want to decide, well, we should have decided, could it be modeled by a line? It looked like it lined up, yes. Then I drew my line. Now I want to write an equation using 2 points. Now I'm going to go ahead and draw on top of my line 2 points that I can use to calculate my slope. So I'm going to use this point right here. And now let's just get one more point that looks like it crosses really well. I think it looks like it crosses really well right there. Okay, so those 2 points are going to be 0, 20, and 8, 4. So you're looking for where the line you just drew crosses a lattice point. Lattice points are where these little up and down lines cross. So that's a lattice point, that's a lattice point, that's a lattice point. You're trying to find where your line that you just drew crosses. So for example, here would be another great place where I feel like my line was crossing a lattice. All right. So I'm going to use those 2 points first to find slope. So slope is always our change in y over our change in x. So the y went from a 20 to a 4. So if I do 4 minus 20, that means that it went down 16 places. For the x, it went from a 0 to an 8. So 8 minus 0 looks like it went forward 8 and down 16. There's my slope. Negative 16 divided by 8 is a negative 2. All right, now let's figure out the y-intercept. Now there are different ways of finding this out. The easiest way, look where your line crossed. Well, mine crossed at about 20 million. So that's my y-intercept here. So my equation is going to be y is equal to negative 2x plus 20. Y equals mx plus b. Now we can interpret this. Let's start with the slope. So the slope, we got a negative 2. I'm going to turn it back to a negative 2 over 1. Now remember that the top part came from the change in y. The bottom part came from the change in x. Well, our y values were sales within the millions. So this is going to be dollars in the millions. And notice how I just labeled the top according to what y is. X was weeks. Now I'm going to go ahead and put this into a sentence. The sales go down by 2 million every 1 week. Okay? And that's how you interpret a slope. Okay, just put those labelings that you have in your table into the slope. The y labels on top, the x labels on bottom. So sales are decreasing by $2 million every week. All right, now let's talk about the y-intercept. Your y-intercept is always where the x was a 0 and then whatever your y value was. We had that. We found that point. We chose it as a point to use, 0, 20. Now remember, x is still weeks, and that is sales. So in other words, during that very first week, we predicted about $20 million in sales. So opening week. $20 million in sales. Okay? And that's it. I hope this helps you. Good luck.